Hi, let's talk about the log functions. If you have a general function log x with the base a, we know that its domain is 0 to infinity because we cannot find the log of negative number or a 0. Let's talk about some other functions. For example, if you have log of x minus 1 with the base 3, so if you have to find out the intercept, we know that there is no y-intercept exist for the log function, but there is a x-intercept. Now, when your x is equal to 1, we get value of function equal to log of 0 with the base 3, and this is not possible. We cannot find this value. That means x is equal to 1 works as the asymptote of the function. Whereas if we will try to find the x-intercept, for that you have to substitute y equal to 0. The value of the function becomes 0. Now, if you apply the exponential definition, that gives you 3 raised to power 0 is equal to x minus 1, x equal to 1 plus 1, the value 2. At x equal to 2, you have x-intercept. You can try to look at the graph. Your intercept is at this point for this function, and at x equal to 1, the asymptote of the function exists. And we can try to find a couple of more values here for 1.5. You can use a calculator for finding the value log with the base 3 for the value 1.5 minus 5, that will come out to be 0.5 here. You can try these values and your graph will have this type of pattern. Let's find domain of one more function. For example, a function gx is equal to log of 2x plus 1 with the base 3. I'm considering a same base. You can change any base here. If we substitute y equal to 0, means the gx value becomes 0. You can use the exponential form of the function, which gives you 3 raised to power 0 is 2x plus 1, and 3 raised to power 0 is 1. If I subtract 1 from both sides, you get 2x equal to 0. It gives you x equal to 0. That means for this function, x equal to 0 is the intercept. Because if we remember the transition of the function, this function is moved toward the left side because you are adding 1 here. And similarly, the log function has x-intercept at 1, 0, but by subtracting 1, you have moved the function to the right by 1 unit. Let's try to look at the graph of the function. Okay, let's note down these points. Now this function has a intercept here. And if you try some value, x equal to 4, the value of the log function will become 9 here, and 9 is 3 square. So you can apply the exponent rule, your answer is 2. At number 4, the graph will have a value 2. And if you look where your asymptote is, you have a asymptote for this function gx whenever your 2x plus 1 becomes 0. And that will exist at a point negative 0.5. This line will work as an asymptote for the function gx, and your graph will look like going in that direction. So these are the two techniques to find the asymptote of the log function and to find the intercept of the log function.